Hello, so today we will be covering everything there is to know about shaders in Godot. How to use them, when to use them, why to use them, and well, this tutorial is split into 3 main sections. From the very basics in example 1 to a step-by-step tutorial on how to create a shader to enhance the look of our game in example 2, and in example 3 using the player input to change how the shader displays on the screen. And my goal today is to explain everything there is to know so you are able to go off and create your own specific shaders to really improve your own Godot games. So just quickly before we get started, it would mean the world if you could subscribe and drop a like to help YouTube push this tutorial on shaders to more aspiring game developers who are looking to create their own Godot games as well. Thanks, and now let's begin. Okay, so example 1. We are in an empty game, empty world. We have a node 2D up here called world example 1, and what we're going to do inside of here is we're going to drag in our Godot icon. In the basics, we're going to go over some basic things, how shaders work, how to add them, what they are, you know, what we can even do. Like, so first, how do we make a shader? Well, let's say we want to add a shader to our icon. We can only add shaders to canvas items. An icon, a sprite 2D, is part of a canvas item, right? So color recs, stuff like that, right? Things that are part of canvas items. A character body 2D is a canvas item. It has a canvas item. It's part of that subclass, right? So things like this, you can add a shader on. If it's not something like that, then you cannot add a shader onto it. And you would have to add a shader onto each thing specifically, right? You can't have a parent that has all the shaders that's going to give a shader to all its children, because that's just not how it works. You have to go over here to the canvas item material. Now, you can load the shader onto other materials because every shader is going to be its own script, and we're going to go over that right now when we create a shader. So if we go over here, we can click on a material, and we can either say new canvas item material, new shader material, or we can load in a material, right? So if we click on a new shader material, we click on this little ball here, you're going to see the shader comes up. If we go down here and we click on this arrow, we can create a new shader, or we can load in an existing shader, which we can save, right? Because we're going to create a script. So if we click on new shader, it's going to let us come up and make a shader. We're just going to name this world example 1 and hopefully save that into the example 1 scene down here, right? But if we click on it, it's going to open up a script. This is a shader script. Now, this is not GD script. This is a shader script. And inside the script, we can remove all of this because we are not going to use any of this, but we are going to use the fragment function. Now, what is the fragment function? Well, this is going to be called for every single pixel within this image. Every pixel inside of this image is going to run through this function. So with that being said, how do we get that pixel? How do we make a variable for that pixel? Well, to do that, we can say a vec4 and we can say pixel color. This is going to be each individual pixel. We can say texture, which is going to be a function, and we can call it texture, and then the UV, which is kind of the coordinates for that pixel within our image. Now, this is going to be a variable for that pixel. Now we can go and we can make changes to this pixel color here, and then we can end up changing our color down below, right? So if we say color, we want the color to equal pixel color like this. What's going to happen? Nothing, right? Because we are just equaling it to itself. What if we were to come here and we were to say pixel color was to equal a vec4, and we put in a number code, right? So we can put in 1, 0, 0, and we can say pixel color dot a. This should theoretically be red if we add in this here at the end, and it's gonna make everything red, right? So let me explain what's going on here. So these are the color numbers, right? Color numbers, if we go to let's go up here, let's add a color rect. Color numbers here, you can kind of see they go through 250. In the script, they only go up to 1. They go from 0 to 1. If we wanted to get an exact color, let's say we wanted to get, 255. Let's say we wanted to make it white. How would we do that? Well, we could just do 1, 1, 1, 1, right? The entire way. Right? And this would end up being a white because it would be maxed out. But really, what if we wanted to get an exact number? So what if we wanted to get this pink? Well, we would have to say these two are max, so those are fine. But then we have 76. So the middle one cannot be 1 because maybe it's going to be 0.7, maybe it's going to be 0.4, somewhere in here, right? It's going to be somewhere in here. But if we wanted that exact color, what would we have to do? Well, it's 74, right? 74 or 76. 76 is not going to work because 76 is greater than 1, so it's going to equal 1 within the script. So we can say 76.0 divided by 255.0, and then we're going to get that exact color, right? So if we go here, we change this. What if we want this purple, right? Well, you see 157. We can go up here to the first color. We can say 157.0 divided by 255, because what this is basically doing is this is getting the whatever the one value is, right? So whatever the one value is for this is, it's going to get that version of it, but it's going to get the exact perfect version of it. So we have the exact color code, right? But that's kind of what that does. But you can kind of see that we take this pixel color, the pixel color that it's giving to us, and we change that pixel color, and we make that pixel color equal to this instead of equal to what it was before, right? And well, that's going to end up equaling it to this right here, right? So our color is now equal to this. Now pixel color here dot A, this is taking the transparency of our existing pixel color. What if we did not want that? What if we wanted it to be half transparent? Well, we can do 0.5, and you're going to see that it kind of goes a little bit invisible, but we don't want this, right? So now I want to go over kind of uniforms, which are variables. We can come up here above the function, and we can say uniform float scale is equal to 1, right? So the scale is equal to 1. What's this? It's scaled at 1 already. But if we go down here, we take our UV, we can say vec4 pixel color equals texture, and then we can get the texture and everything. And then we can take this UV, the coordinate, and we can multiply it, right? So we can say boom, and we can multiply it by scale and see what does it? Nothing, right? Because it's equal to 1. What if we equal it to 3? What's going to happen now? You're going to see it changes. It scales it up. What if we do to 10? See, it's going to make it 10 times smaller. What if we did 0.5? It's going to make it bigger though, right? See, now it's going to be bigger. But, you know, normal scale, we want it to be at 1, and that's going to be the normal scale. So that's kind of how scaling works. Now, what if we wanted to create an exported var, and what if we wanted to create like a little tilt? Well, that would be distortion. So we can come up here, we can create another variable. We can say uniform. And this is all going to make so much sense when we get into actual examples in example 2 and example 3. But if we say distorted value, and we can make hint range, this is going to allow us to have an exported variable from the range that we are like a little slider, so we can kind of test it out like real time, which is going to be really cool in just a second. But we can say the value, maybe we want it to be at -5 at the minimum, and then maybe 5 at the maximum. And at the beginning, we can say it's equal to 0. Now, what this is going to do at the beginning is it's not going to have any distortion at the very start. But a distortion is going to be a little bit more complex. And what we're going to do with that is we're going to have to come up here just like this. And we're going to create a vec2. And vec2 is going to be a new variable. And we can name it distorted UV. And basically distorted UV is going to just be equal to UV for now, and then down here is where we're going to change it. So we can say distorted UV, so we can basically get our UV dot x plus equals distorted UV dot y, and then we can times this by the distorted value, right? Which is whatever value we have up here, and that's how it's going to tilt it. And we can change up these axes to have it tilted different. And then, of course, we're going to have to come down here, and instead of taking the pixel color, we can say the distorted UV. Or actually, we want to take this so we have the same texture. So we can put it up here, and we can say distorted UV just like this, right? And we can make this back, and we can say this is pixel color just like this. Okay, so now what's going to end up happening? Okay, and this is giving us an error here because we have to have this under the distorted. So we need to put this above the pixel color up here, right? And then we can remove these, and we can add a little space down here just like this. And pixel color here spelt wrong, and we do not have a ending for our distorted value, but that should work. Okay, that works. So if we go to our icon and we come over here to our shader, we can see shader parameters. We can see distorted value, and we can move this slider because this is what the hint range here is. If we move it along, you see what happens. It kind of distorts it. What if we change up these axes? What if we say X and we say Y? what's going to happen now? Well, if we move this stuff around, it's going to go up and down. What if we say Y and Y? What's going to happen here? Well, it's going to do something kind of funky. It's going to like kind of squish and stretch it, which is pretty cool. So this is max. This is at 5. It kind of gets squished and then we get stretched, right? So that's kind of how you can mess around with distorted. But what if we wanted to kind of change the color of different pixels on the screen based on what those pixels are? What if we wanted to do something like a grayscale? Well, changing the color is, we're going to kind of go over here in just a minute, and it's going to be basically checking the RGB of it. I forget what order. I keep trying to say RBG, but that's not how it is. It's RGB, right? We can check if, like, let's say the pixel color dot G is greater than 50. Then we can say, okay, if it's greater than 50, then we want to change it to this color. But right now we're going to do something very basic. This is a very basic color change, and it's not really going to take the color. It's just going to grab it and change it into a grayscale by changing the colors of everything down, right, by just a little bit. And I'll explain how it works here in just a second. But if we go under, we can create a float, and we can name this as brightness, and we can say this equals pixel color dot R plus pixel color dot G plus pixel color dot B, and then we can say slash the brightness value, which we're going to have to go and create, right? So if we come up here, we create a brightness value. We can say something like uniform brightness value. And what's brightness value going to end up being? Well, brightness value is going to have to be about 3. Let's see. So we can change it. We can see what happens, right? We can say hint, and we can say maybe hint range from maybe 0 to 10, and we can see what works best, right? So we can say equals to 3 for now, and then we can come down here. This should work, and then we have to create one more vector, and this vector is going to be a vect4, and it's going to be just like our pixel color, but we're going to end up naming it gray color, right? Because it's going to be our grayscale. So we can say vect4, and then we can grab our brightness that we just created, the variable. And what brightness here is going to end up doing is this is going to set the R to the brightness color. It's going to set the G to the brightness color, and it's going to set the B to the brightness color. What's this going to do? Well, it's going to make every single number the same, because we divide it and we basically grab the average. And then we can say pixel color dot A, so it's still, you know, a 1. It's still visible. And then down here we can say gray color, and that's going to instantly put it into a grayscale, right? Okay, so we have we forgot to put float up here at the top, and that should go. We have distorted UV, which remember we remove, so we do have to remove that as well. And we have another error. We forgot to end off this line, and there we go. We have gray. But why does gray work, right? If we go to our color rect and we come over here and we make everything equal to the exact same, it's going to be white. If we go over here on the gray and we move it up this grayscale, you see every single color is always equal to the exact same color. So that's what we're basically doing, is we're grabbing the average to create a basic grayscale. Now, if we go to our icon and we come over here to our material and we can change up the shader parameters, we can move the brightness and see what happens when we play with them, right? It gets darker if we go up, and it gets lighter if we go down. And that's kind of how that works. So that's how you create a basic grayscale. But what if we wanted to kind of remove everything, what I was talking about just a minute ago, but just leave a color? So let's remove the grayscale here, completely remove the grayscale. And then down here we have to do pixel color. Okay, this is the last thing that I'm going to go over here in the example 1 before we get into example 2 and go over the real examples. But if we grab our pixel color and then we say something like an if statement, which we can create within this script, we can say if maybe pixel color dot B is greater than something blue, right? Something blue. Maybe we can go to our color rect and we can come over here. we can grab this color switcher and we can kind of see. So this blue, let's get the blue. So we can see this blue is equal to 191. This blue is equal to 82. This blue is equal to 50. This blue here is equal to 66. So they're all about over 50. So we can say just this is the highest one, right? So we can say if the blue is higher than 200, which is only the white, if the blue is higher than 200, then we're going to want to leave it. So we can say if blue is greater than 200 divided by 255, right? Then we want to say, with the curly brackets, we can say pixel color dot a is equal to 0.0, and that's going to be invisible. And you can kind of see how that works, right? And that's going to be an if statement, and it's going to remove everything else. What if we said that it's equal to visible? Well, then what's going to happen? It's going to leave it. But what this is doing here is it's making anything that's greater invisible, and I guess it's making anything under invisible. So we would have to flip this here. If we flip it, then it's going to do the opposite, right? Because now it's saying, okay, white is greater than this number, so now we want to hide it. But yeah, so if we did this, then it would make it invisible, right? Because we're grabbing this number, which is whatever this is, about 0.8, and that's going to end up being higher than all the others because we checked with the color picker, right? And we went to a color wheel and did it legitimately. But that's a very basic overview of shaders and how they can be added to change different pixels and different movements and distortion and stuff like that within Godot, within the shaders. But now let's move on to a little game where we're going to learn to make a water shader, which is an actual shader that's going to be useful. Maybe you can use it for your own game, and maybe you can use things within that shader to make something to enhance the color of the pixels, because we're going to be going over everything in this tutorial. So let's get into that. Let's make a little water shader in example 2, and then we're going to move into example 3, which is where we're going to make a pressure plate. If we click it, then it's going to turn a shader on and off by changing a variable from a GD script. So it's going to be pretty entertaining, and it's probably going to be pretty informative as well. So let's get into example 2 and let's learn about wave shaders. Okay, so example 2, right now, if we click play on the game, we have absolutely nothing. The water does not move, nothing even happens. How are we going to go about this? Well, to start, we're going to go up here to the top. We're going to add a new color rect, and we're just going to move this color rect over here for testing for now, right? And then we'll come back to our project. So this color rect, what are we going to do? Well, let's set it to a watercolor. This is not going to be the official watercolor. This is not what we're going to use for the waves, but we'll set it for this for now. Now, this color rect we can rename to testing, and then we can come over here to material. We can go into shader, and we can click on new shader. We can add a new shader to this, and we can name it world example 2, because that's what it is. It's for our world example 2, and we can just name this shader here and create it. Now, if we click on this shader, we're going to have a blank canvas to work with. Now, inside of this shader, what are we even going to do? What is our thought process? Well, we're going to have a ton of variables. We can remove this, and we can remove vortex to keep everything as simple as possible. Now, here we're going to want to say a variable. We can say uniform float progress, right? And this is going to make sense. This is all going to be able to be changed from our uniform, or from our parameters. We can say float the frequency of the wave, and for now we can say 2.5. We're of course going to change that later. And then we can say uniform float the amplitude of the wave, which is going to be, I guess, 1 for now, 0.1 for now. And then we can say uniform float speed equals 2 for now, and then we can change that later as well. So that's just very basic stuff. And then we're going to have 2 more uniform floats, but these are going to be colors, so we can end up having colors. So the wave is going to consist of 2 colors. It's going to have to consist of 2 colors. If you want the background transparent, then you can make that color a transparent color, right? So you'll be able to see right through it. But we can say vec4 background color, which is going to be equal to a source color. And what this is going to do is going to allow us to pick a color. So then we can say uniform vec4 the wave color, which then we can say source color as well. And let's go over here to the test. You can see shader parameters. If we open this, you can see everything that we have. What if we want the background to be transparent? Well, we can do that. What if we want the wave color to be equal to the color of our wave over here? Well, we can do that. Now that it's equal to that, but we can't see anything because it doesn't call those anywhere. It doesn't even take these, but you can kind of see our background colors are in our wave color. If we come down into the fragment, we can say something like vec4 wave, and then we can add in the wave to the color of the color rec. And to do this, we're going to actually have to go out and we're going to have to create a new function. So we can create a function outside of the void function that we can call from the fragment function, or outside of the fragment function that we can call from the fragment function. If we say vec4 wave, and then we can pass through whatever we're going to want to pass through, we're going to have to pass through our UV. So we'll pass through our UV variable, and then we can do curly brackets, and then we can say float, and then we can say sinus equals sin, and inside of here is going to be uv.x plus time times the speed of our wave, which is our variable, and then we're going to want to times this by frequency. And this equation that we're putting together right now is a basic wave equation, or basic it's like a sound wave equation that you can find in physics or anywhere, right? But this is kind of how a wave is put together, or how a sound wave is put together. And then what we'll do is we'll return wave color, right? And then because our wave color is going to be from this exported variable out here, and then we can times this here by step 1.0 minus whatever we get from that sinus function up there, and then we can equal this, or we can minus the progress, and then uv dot y, because we want it to be going horizontally and not vertically. And if we change this, then the wave will go vertically. But if we come down here into fragment and we say vec4 wave, which is the variable, and we can call our wave function that we just created, and we can pass through uv, which is each individual pixel. And then we can say we want the color dot RGB to equal a mix of the background color. So then it's going to be like two lines going throughout. So we want it to mix the background color and the wave. And then we want it to equal wave.a, which is going to be fully transparent dot RGB. And theoretically that should work. And there you go, right? That's a wave. It's pretty wavy and it looks good, and we can go in and we can change up all these functions. Now, of course, the transparency here, the background color is a different color and the water is a different color, because it's not really, it's basically two colors and it's changing the pixels as it goes. That's why we have this background color equaling the first, and then this wave equaling the second, and then we're going to grab the transparency of whatever we want the transparency to be. So if we wanted the transparency to be half, we can make that half, and it's going to make it half, right? Or we can just make it 1, because it's never really going to not be 1, right? But we're going to go here, and we're going to say wave.a. Wave.a. We're going to grab our background color. We're going to equal our background color to the sky. We're going to equal our wave color to the water. And then we can come over here and we can move this in. So instead of water body, we're actually not going to touch this. We're going to come to water body. We're going to come down here and we're going to go to our material. We're going to create a new shader for our water body, and we can load in the shader that we just created. So it should be an example 2 scene. We can load in our shader, and you can kind of see how that works. Now, this is automatically going to load it into this one, which is not exactly what we want, but we can go in and we can change everything however we want to, right? So maybe we want it, we can just leave it all at this, and then we can go to this one over here. We can maybe change the frequency to maybe 2. Okay, it's going to end up changing both because I copied and pasted these color recs over here over. So we can remove this rect. And then this rect here, we can kind of keep whatever's here. We can move our amplitude to maybe 0.05 like it was. And then we can bring this up, of course. We can expand it down, which is going to kind of stretch it a little bit. But something like that. It looks like a wave. It looks like it's kind of going. Maybe the speed needs to be a little bit down. Maybe the frequency needs to be a little bit down as well. And now it's like a slower wave. Maybe the speed needs to be a little quicker. Maybe a little too quick. Maybe the progress. See, the progress is going to be the fill level in the thing. So what if we did 0.8? Well, it's going to be much higher, right? But we'll just leave it 0.5 so it's in the middle. And that's going to look good, right? So that looks like it's a wave. Now, if we grab this, this is our other color rect. We can rename this to water body 2. Or, no, we're going to leave this as test. And then we can come up here and we can grab another color rect. This color rect, we can go to material and we can new shader material and we can end up loading that same script, and you're going to see what happens here. We're going to have to click on it, shader parameters. We can grab the background color, whatever we want the background color to be, and we can grab the wave color. And this one here, we're going to want it to be a little bit more rocky, right? Because it's an ocean. We want the speed to be negative because now it's going to be coming and it's going to look like it's hitting this wall instead of going away from it. Amplitude, maybe we want that down by a little bit, just maybe a tiny bit, maybe even a little bit more than that, right? Frequency, maybe we want that down as well. And then progress, same thing. It's okay as it is. And you're going to kind of see how this goes. If we click play, our water now has a little bit of animation. It has a little bit of movement. It's not as bare as it used to be. And that looks good, right? So that's nice. These are two completely different separate water areas. So they're not interacting with each other. They're using the same shader, but they're not interacting with each other, which is how we want it to be, right? So that's how we're going to go, and that's how we're going to create a wave. Now I want to move into example 3, where we're going to take on-screen input, player input, user input, and then we're going to change the shader based on the input that we go. And we're also going to go over how to change the color of different pixels on the screen based on what the color is of that existing pixel, right? So let's move into example 3 and let's learn about that. Okay, so in example 3, we don't really have much. If we click play, we have a player, we have a little world, and we have a little pressure plate. If we jump on it, then it's going to, nothing's going to happen, but it's going to end up going up here into this, and it's going to should print off something. I guess it's not, I guess we have it hidden over here. So it is printing off something. We just have it hidden. So if we click play in our world 3, we jump on top of this pressure plate, you're going to see down there in the output, it's going to print off every time we jump on it. But we want, whenever we jump on it, we want that to end up changing the shader that we have, right? We want that to change the existing shader. So how are we going to go about that? Well, we're going to go to our tile map and we're just going to add a shader. We're going to keep it basic and add a shader to our tile map. We can say new shader material and we can create a brand new shader. Now, this shader here is going to be a very, very basic one at the beginning. And to do this, we are going to create a variable, and this variable is going to see if the shader is on or off. So we can say uniform float on off equals o dot. Right, so this is a variable, and we're going to go over to the shader parameters, and we can equal it to 1, or we can equal it to 0, based on if we want the shader to be on or off. Now, if we go into the fragment here, we can say something like vec4, like we have to have in everything. We can say pixel color equals texture, and this can equal texture UV, just like it has to equal. And then we can come down here and we can say something to quickly invert the color. So we want to invert the pixel whenever the shader's on. So we can say vec4 color equals vec4. But the magic with this here is going to be what we do in GD script and how we access these variables. So we can say dot 1 minus pixel color. This is basically going to just flip-flop the color. RGB pixel color dot a, and then down here we're gonna just basically see if that on or off function, what it's equal to. If on off is greater than o.5, then that means we want the the scene to be on, right? So if that is true, then we want color, because we want it to be on. We say color equals the color, right? So this is going to equal this color here. So if this is on, then we're going to invert it. If it's not on, then we're not going to invert it. So how are we going to go about that? Well, if we go to 2D real quick, let me just show you what it looks like. If on or off over here is equal to 1, it's going to look like that. If on or off is equal to 0, it's going to look like that, right? So if we go up here to World 3 example, when we click on the pressure plate, we have print pressure plate. Now, inside of this script, we have our get ready variable to grab the tile map. Now, if we get that tile map, because that's what our shader is attached to, remember our shader is attached to that. Let's remove this. And let's say var shader status. Shader status is going to be equal to tile map dot material, and then we can say get shader parameter. It's not going to autocorrect for this, which is very weird. It does not give you a help whenever you're doing this get shader parameter or set shader parameter, and we can put in our name, right? So that's going to be the shader. That's the variable that we want to pull out, right? So on our player, we have a function variable. And the reason I have that is so we can keep it basic here and we don't have to instance the player or anything. We can just say if player has, or if body has method player, then we want to, first of all, we can say print the shader status so we can see that it works, you know, correctly. And then we can say if shader status is greater than 0.5, that means we want it to be on. Then we can say, all right, well, that means we clicked it, right? And that means it was on. That means we want to turn it off. So we can say tilemap dot material dot set shader parameter, and then on off, and then we can say 0.0 on off 0.0. So we want it to set it to equals 0.0. And then if we go down, if we say if shader status is less than 0.5, that means it was already off. So we want to set it to equal to on. If we click play on the world, you're going to see that if we jump on it, it's going to change it. If we jump on it again, it's going to change it back, right? Back and forth, and it's going to print out that shader parameter. So this is how you're going to get shader parameters. And this is how you're going to change the shader parameter or the shader variables. And this can be anything. This can be scale. This can be how heavy the waves are, right? In our other example, we can change the amplitude. We can change the everything, the speed, anything that you would need to change, right? You could change it through script by using this function here, right? So that is kind of all that there is to this video. I'm hoping you were able to find something useful. I want to thank you so much for watching. And I also want to mention that getting good at shaders and learning shaders, how they work, what they do, takes a lot of studying the colors. You have to know the colors. You have to know the RGB. You have to know what brightness does to pixels and what brightness does to this color and that color and how colors work. So you have to have knowledge of colors and how they affect and how pixels are going to affect the screen based on, you know, whatever the function may be that you're creating with the shader, right? So it just takes a lot of practicing, a lot of trial and error, and kind of a little bit of knowing what you're doing, right? So it's complex. I would have to say it is pretty complex for shaders. They are going to get frustrating pretty quick. What I recommend doing is asking for help. If you need help, ask for help with shaders, because you could ask someone and they know what they're doing. They can give you a point, and then you ask someone else and they give you another point, and you're like, oh, whoa. And then you're going to get an idea, and you can add those two ideas together and come up with something that's absolutely amazing. But yeah, my number one tip is just learn how they work, trying to study the colors and what happens if this happens to the color and what happens if that happens, what's going to happen with movement, with variables and functions, and what, like, take things and I don't know, you can take physics equations, right? You can, just like we did over here, you can take physics equations and you can put them together and you can make something with a shader, right? And that's what's pretty cool about it. And that's super cool. But yeah, I want to thank you so much for watching. I really do hope you were able to find something helpful within this tutorial. And if you were, then please let me know in the comments down below. If you need any more help, then please let me know in the comments down below. If you didn't understand anything, please let me know, and I will be sure to get back to you. But thank you so much for watching. And until next time, subscribe, drop a like, push this video to more aspiring game developers so we can grow this Godot community and learn to create games together. It means the world, and thank you so much. Good luck on your game dev journey. Wishing you the best of luck, and be safe today. Thank you, and bye-bye.